Previously, we discussed simple regression model and OLS estimation in Mathematica. 50,000 household income consumption data points were generated. Data were exported in text files. We import the data again. Scatter plot of 50,000 monthly income consumption pairs. And scatter with OLS best line.
In this lesson, we'll extract two subsamples from our population of 50,000 data points. We'll study and compare the scatter plots as well as OLS regression lines. Let's extract only 50 income consumption pairs from 50,000 data points. Name the list. Pick income consumption. This is what happened. These are 50,000 natural numbers. Here we tell Mathematica to start with 1 and then pick every 1,000th. So it picks 1 and then 1,001th, then 2,001th. And so on until 49,001th. So length of the vector is 50. Let's look at the scatter plot of these pick income consumption points. Even in this 50 points plot, we can notice the heteroscedasticity. As the household income increases, consumption variability increases. That is, graph widens vertically as we move away from y-axis towards right. This is one of the violations of classical linear regression model. Define X matrix in Mathematica. It has 2 columns and 50 rows. Define Y vector of 50 consumption observations. Define the matrix formula for beta vector. And here we get the values for intercept and slope. Let's convert the regression equation into picture. Plot of the regression line. Show scatter and the regression line together. The OLS. Best fit.
Now, let's look into another dimension of the data analysis. The monthly income data is distributed into 3 ranges of incomes. These are random integers or whole numbers. Low income, $400 to $800. Middle income, $800 to $5,000. And high income, $5,000 to $6,500. Also, out of 50,000 households, 30,000 are in middle income group and 10,000 each in low and high income groups. Take a look at the income list. Population of 50,000 elements. Here is the frequency table, called tally, in Mathematica. It shows how many times a randomly selected income is repeated in the data. For example, the number 400 is used 34 times, 401 20 times, and so on. Different integers are selected randomly, greater than or equal to 400 and less than or equal to 6,500. In case of consumption, however, because of fractional MPC multiplier, the consumption figures are continuous values with fractions. So all 50,000 consumption figures are unique real numbers. It means that there are instances for households with same monthly income having different monthly consumption. To confirm, we can look at frequency table by using tally function. All. The consumption figures are unique. Tally is one for all.
For our regression analysis of 50 data points, if we consider other consumption levels for the same income level, 540 additional points are added to make the new sample size of 590 observations. Let's revise our analysis for it. Pick income is the list of 50 income levels we selected to analyze. All the 50 selected income levels are unique. As this count function confirms. To extract other consumption points on the same income level, we can use loop function 4 of Mathematica. It has 4 arguments: start, test, increment, and body. We tell Mathematica to start with 2 empty lists: consumption at pick income and list consumption. Another start is iterator I equal to 1. For every iteration, 50,000 income values are checked, and if it matches with pick income, corresponding consumption value is appended in the appropriate place in empty spaces of new consumption list. Test for iterator, to stop loop, is I being less than 51. After using the for loop, the output is a list of 50 lists of consumption levels, one for each income level we are interested in. When we flatten this list of lists, Mathematica tells that it contains 590 elements. Here we extract the info, that which income is repeated how many times. Here we prepare lists of 590 points to be shown in the scatter plot. This is the scatter plot of 540 additional points stacked upon same 50 income levels selected. Compare it with this plot of earlier 50 points. They are also included in the above 590 points plot. Here is the plot of 590 points with 50 earlier points highlighted red in color. Let's draw red dotted lines through these points to make them more prominent. Here is the plot with 50 points. On these lines, in addition, 2 small blue dots as extreme points. All of it on 50,000 data points together. It's time to prepare for regression in the case of 590 data points. Code the X matrix. I vector. Code the formula for beta vector. Draw the OLS line. Show the scatter and the line. Here are both lines with scatter. Thick blue line is for 590 points, and the other for 50 points. Here is plot with 3 lines. The red line is for population of 50,000 points. In this last plot, we show all the apparatus. The big green points represent the 50 data points we started the lesson with.